While drive-offs simulated in this video are not designed to precisely reflect what happens when a hose is connected to a nozzle coming out of a side gas tank, they do provide an idea of the elasticity and/or performance of the various hoses depicted when pulled in a straight line with fairly consistent force. Further, there are other variables in actual drive-off events that could impact the performance of equipment, so VST recommends that hoses and related equipment be inspected after every drive-off incident and before the next use. Here you see a still shot of the recoil of a hose snapping back. Hello and welcome to this short video where we compare the performance of 3 different hoses as they experience a simulated drive-off. Each of the hoses are configured with a VST 12-inch whip hose and a VST breakaway. We are presenting the performance of, first off, the VST standard EVR balance hose, next a competitor hose, and finally the VST Platinum hose. These simulated drive-offs were conducted in August of 2016. There are critical concerns with hoses following drive-offs, such as how the hose reacts during the event and what is the condition of the hose afterwards. Is the hose still in working condition? All balance hoses require a liquid evacuation method to eliminate system back pressure, which prevents ISD alarms. The consistent positioning of the evacuation tube and filter is essential for the effective evacuation of the liquid during fueling events. This graphic shows CARB's requirements for the liquid removal device. Tests show that for this device to work properly, it should deviate no more than 3 inches to the left or to the right of its sweet spot on the hose. This limit is necessary to ensure that the device is in position to prevent blockage of the vapor path by accumulated fluid. For example, pictured here is the VST EVR standard balance hose. Notice the white mark delineating the perfect positioning of the pickup tube and filter on a brand new hose. Now let's watch as the VST standard EVR balance hose experiences a simulated 6 mph drive-off and see the effect of the drive-off on the positioning of the pickup tube. Notice that the pickup tube moved approximately 3/4 of an inch after the first pull test, but moved no further after the second pull test, in which case the pickup tube is still well within the 3-inch deviation, meaning the hose will still work properly after the drive-off. Now let's see what happens with a competitor's hose. Notice this particular example has 2 pickup tubes versus the VST standard EVR balance hose, which only has 1. The pickup tubes moved 4 inches after the first pull test, and they moved an additional 2 inches after the second pull test for a total of 6 inches of movement, putting them well outside of the CARB allowable 3-inch tolerance. They are now out of position to remove fluid blockage. VST lab tests show that if one of the pickup tubes is out of the fluid, the single tube is not able to evacuate fluid according to CARB standards. Okay, now let's see what happens with the VST Platinum hose. Notice how the Platinum hose just dropped, and its breakaway motion is much less dramatic, creating a softer separation. Current hoses stretch approximately 30% and then snap back after the breakaway releases because of the energy buildup, but not the Platinum. And notice the after effects. On the Platinum hose, the pickup tube stayed stationary through the first pull test. It remained stationary through the second pull test. In fact, it never moved after 16 pull tests. So to recap, the VST standard EVR balance hose moved 3/4 of an inch in the first simulation, but didn't move any more in the second simulation. So even after 2 simulated drive-offs, the hose would still perform satisfactorily because the pickup tubes remained well within the 3-inch tolerance. The competitor hose didn't fare so well, moving a total of 6 inches through the 2 drive-off simulations. It's very questionable if the hose could continue to perform because of how far out of tolerance the pickup tubes are. And finally, the Platinum, who after 16 simulations has absolutely no movement whatsoever, whose disconnection from the breakaway floated easily to the ground, thus mitigating potential damage to surrounding equipment and injury to nearby customers. Watch it again. Compared to this. VST Platinum Hose, the engineered solution that takes a drive-off from a potentially destructive event to a relatively soft recoil, reducing the risk of injury to your customer and damage to your property, including your site equipment. It's your ultimate risk management tool. You have reached the end of this video.